welcome to our third webinar. This is the third edition of our community training webinars. First one we're doing in English, the previous two were in Hebrew. We're in the process of building a global community of voice service builders that will enable you, that will empower them to build new types of telecommunication networks and applications in novel new ways, not using the traditional tools that most of us had been using for the past 10, 15, sometimes some of us 20 years. As I said, my name is Nir. I'm the CEO and founder of Cloudonics, and I'm going to tell you all about that in a few seconds. So let's begin. So before we begin, just a little bit about our webinar series and what we're here about. So we have two message groups. One is a WhatsApp group. The other one is a Signal group. These are low volume announcement groups. They're used mainly to announce new webinars, new training material that we issue out, and you can find either on our website or inside our YouTube channel that you'll be able to log on to later on. We also have a community Slack channel that you can use, that you can join. The community Slack is designed mainly for developers to be able to log on and discuss various issues, either using Cloudonics or sometimes other technologies that are related to what we do. A little bit about myself. I'm the CEO and founder of Cloudonics. Some of you know me already from your past. I've been an Asterisk developer, Camilio developer for the better part of the last 20 years. I've worked with a lot of companies and a lot of global brands, building various telecommunication networks. And I've taken all of that experience, coupled with Eric Klein, who's here as my co-panelist, and Oded Albel, who is not part of this, is not in this session right now. And we've basically built something else. We're not going to talk about Cloudonics, about what it is. We can later on talk about that. We're here to talk about something else, and that is building large-scale telephony networks. Most of us at any given time in our career had been confronted with the question of building a large-scale telephony network. It could be a multi-office, a global enterprise that has offices all over the world. For example, in the past, we've been asked to build a network of 16 different sites for a specific company. And the problem with all of these networks is there's always two questions. First question is, what is a large telephony network? How many sites does it require to be a large network? So this is where the webinar is going to be a little bit interactive. And now the question comes back to you. And using the chat, using the Zoom chat, I would like you to tell me, what do you think? How many sites does it require for a corporate telephony network to be classified as large, or maybe even extremely large? What do you think? I'm looking at the chat and I'm waiting for your answers. Emmanuel, I think you're referring to extensions. Sites, namely individual PBXs or individual systems. Anything more than 2? 3? Okay, what other answers? Okay. Okay, so amazingly, and okay, 5. Okay, so amazingly enough, and actually 2 people got it right, is that any network that has 3 sites and more, which means more than 2, will be considered a large network. And the primary reason for it is not because it means that you have a lot of extensions or you have a lot of people connected to it. Absolutely not. It basically refers to the amount of work that you have to invest into building said network. So when building a large scale network, there are four different approaches that either vendors or integrators normally pick. They will normally take one of the four options. So one of the options is using SIP domains with Srv records. So this is a very common solution where we're talking about platforms such as, for example, Avaya or Cisco. They like doing that. Why? Because it is considered standard. It is considered something that you can set up quite easily. And in most corporates, most enterprises, you will have a centralized DNS capability. So for example, if we're talking about a Microsoft-based web, company, then we're going to have Active Directory, going to have Azure Active Directory. So we're going to have these tools built in. The primary issue with implementing SIP Srv domains is that they're not really that easy to implement. That's number one. And in most cases will require some vendor assistance. And I put vendor in double quotes because we don't know what the vendor capability is. Sometimes some systems don't support that easily. And it will require us to tweak the system. In some systems that I've seen in the past, actually, SIP Srv is so badly supported that if you have a platform that is built from multiple vendors, for example, 2 or 3 different vendors, the result will be that it will be potentially impossible to implement. Next in line is something called a full mesh interconnect. Now, a full mesh interconnect is nominally what most people do. Why do they do that? Because they believe that, number one, they will achieve better redundancy and reliability. And that is true because it means that every site is interconnected with any other site as well. So if we have 5 sites, we have for each site, there are 4 outbound connections to each one of the other sites. Now, if we're talking about redundancy and reliability, yes, that makes perfect sense. That capability is very reliable. But the primary thing is that the minute your number of nodes, in this case, the number of sites you need to manage goes beyond 4, the number of connections that you have to configure for every step of the way expands exponentially. And I'll show you what that means and why it happens. The next in line is the star-based interconnect. Now, star-based interconnects are extremely simple. It means that you have some kind of entity in the middle, okay? And that entity basically routes calls between everybody else. The primary advantage here, it's extremely simple to set up. Adding new endpoints doesn't add complexity. Problem, routing core becomes a single point of failure. So you need to manage that star, that switch in the middle to make sure it always works the right way. Another thing is that in many cases, that star rapidly becomes more than just a routing engine. People start using it for other things. And at that point is where things start to break. Star-based topologies are very much common when you use something, let's say, like the session border controller. So companies will put a session border controller as their primary routing point, and all the elements will connect to it. It's a valid solution, a little bit expensive, but it will do the work very, very well. The fourth capability is, or the fourth solution will be a vendor-specific solution. For example, Avaya has their own concept of how to interconnect between sites, how to create DRP solutions. Same applies to Cisco, same applies to other vendors. There's a lot, the advantage here is a little, no headaches. But from a technical perspective, from a business perspective, we have a significant vendor lock-in because all of these technologies normally do not interoperate very well with each other, if at all. So for example, I won't be able to build a cluster that takes, for example, an Avaya system and then a Cisco system and tell them, okay, you back up on each other, it just won't work. It doesn't work like that. Vendors don't like to play that well between themselves. So we previously said that any installation that has 3 sites and above should be considered a large installation. That's number one. Number two is that the more sites you have inside your installation, the complexity of managing the system goes up exponentially. And I'll show you why that happens. So here's what we have: 2 different topologies. On the left, we'll have the full mesh. The full mesh basically has every site is interconnected with the other. On the right-hand side, we have a star topology. There's a centralized routing entity, and basically everybody is connected to it. Now, if we look at the two, we can definitely see that the number of interconnects, assuming that you want to make sure that you have, let's say, inbound and outbounds, eventually the number of interconnects per site here is very much identical. Okay, because here we're going to potentially have, if we have 2 centralized locations here with an active solution or some kind of backup, so there'll be 2 links here, 2 links here, 2 links here. And here we have, again, 2 links, 2 links, and 2 links. So it's very much identical on all sides. Now, when we're talking about 3 sites, so whatever you pick, the overhead is identical. There is no difference. But here's what happens when you go to 4. Now with 4, on the left-hand side, you can see that every side needs 3 interconnects and 3 call routes. On the right-hand side, you can see that every side will require 2 interconnects, assuming that you have 2 sites to load balance or to provide active-passive configurations. And then you have 1 call route assigned for every situation. So one will say, okay, so no big deal. So here I'll have 3, 12, here I'm going to have 8. The difference is not that much. True. But here's what happens with 5. Now with 5, this gets really complex because you have 4 interconnects, 4 call routes per server. So it means that your potential points of failure goes up to like 5 to the power of 4, which is kind of crazy. Here, still 2 interconnects per site, 1 call route per site. So the overall complexity of a mesh that provides you full redundancy and full reliability is, that's the pro, but the con is complexity and manageability. On the right-hand side, we got star topology, which has simplicity, simple management, but if you do it the wrong way, you have a potential single point of failure. So the logic here that applies is very much the same logic that you would apply with normal IP networks. Sorry. So the question be, this entity at the middle, the star, okay, that switching tool, what tools and what solutions do we have in order to build that? So we all know the open source solutions, Asterisk, Chameleon, FreeSwitch, OpenSIPs. Depending on the size of your network, a different one will apply. If you have a lot of interconnectivity between the sites, Chameleon and OpenSIPs will be the solutions. Asterisk and FreeSwitch are simpler to use. Vendor equipment, vendor solutions. So of course we have the various SBCs, Acme Packet, we got from Telco Bridges, we got from Sangoma, audio codes. There's a multitude of these solutions. Again, each one of them will require vendor participation and an integrator to come in and do the work for you. But today, we got to the point where we have cloud solutions. And I'm not talking here about an SBC in the cloud. So for example, like audio codes or telco bridges or Acme Packet. I'm actually talking about the ability to take CPaaS solutions, what we refer to as communication platform as a service, and then use these as your inter-site connectivity. So here you can use we're gonna demo with Cloudonics, but you can do very similar solution using Twilio, Plivo, SignalWire. All of them have what's called BYOC capabilities, which are known as bring your own carrier. They're priced differently, they have different capabilities, and they have different limitations. For example, has any of you used BYOC on Twilio, for example? If you have, raise your hand or say I did or something like that. Okay, so nobody did. So for example, BYOC solutions on Twilio require you to use from domains that only they give you. So the result is that in many cases, that interconnect can be a little complex because their BYOC solution is designed for something very specific. But the thing is that you can work with these platforms with relatively, I would say, almost no configurations or no special configurations in order to build your network quite rapidly. And I'll give you an example. So we're going to do a hands-on session, basically, where I'm going to show you an interconnect between 3 sites using Cloudonics as your switching environment and Pipedream as your routing logic. Now, anybody here know what Pipedream is? Is familiar with that tool? Okay, wow, nobody's familiar with Pipedream. Okay, so today there are various tools out there, various services that provide you what's called either no code or low code capabilities. Tools like Pipedream, Integromat, Zapier, Rapid API, and so on. These tools enable you to tie in, or let's say connect between various APIs rapidly without writing code that is too complex, and sometimes without writing any type of code. So what we're going to do would look something like this. So we're going to have 3 different free PBX systems that are going to be interconnected with Cloudonics. And Cloudonics is going to use something we call CXML. It's effectively a programming language that we use, very similar. If you're familiar with Twilio's TwyML, it's fairly similar to interconnect with Pipedream and build the routing logic in there. So let me show you how we did it. So I'm going to remove the share. Go something else. Okay, so show the browser here. Here we go. Here we go. So here we have our 3 asterisk-based free PBX systems. These are standard free PBX distros downloaded from the internet. Basically, they're currently operational inside Voltaire. If you're familiar with a cloud environment called VULTR, voltaire.com. So this is where they're currently hosted. Sorry. So we have 3 of them, as you can see. And on each one of these, we've defined a single trunk. All the same trunk. Border Cloudonics IO. So Cloudonics operates 2 different endpoints. One is called border, the other one is called subscribers. Border is designed for carriers and on-premise platforms, while subscribers is designed for normal registration endpoints such as soft phones and IP phones. I'm going to demo here 2 very unique capabilities that Cloudonics does out of the box that you're going to really like. So as you can see, you have 3 different systems. And the primary difference here between them is that this one uses ULaw, this one uses G729, and this one uses ALaw. One of the things Cloudonics does out of the box is the ability to do on-the-fly transcoding without even asking what the codec should be. So here is our Cloudonic system. So I'm going to look at this domain. Here we go. So here you can see that we have 3 sites. So we have 3 outbound trunks. You can see them here. Okay. And we'll go back into domains. And we have 3 inbound trunks. Again, coming from the same IP numbers. They're identical. Now, we're going to go trunks. Now we're going to go into what's called applications. Now, applications in Cloudonics, as I said previously, are basically your tool to provide logic. So if you're coming from the Asterisk world, it will be your equivalent of mashing up the dial plan with AGI at the same time. So what I created here basically is a pipe dream URL. As you can see, we'll see what this does in a couple of seconds. And I'm effectively telling the system, okay, if anybody dials any extension in the realm of 3, starts with 3, then 4, 5, 6, and 2 more digits, this is the application that you need to activate. So what will happen in our case is that each of the Astra systems is now configured to send the outbound calls to the single trunk that it has, in this case, the Cloudonic system. So what does this thing actually do? So let's have a look here. Sorry. So let's have a look here in the Cloudonics script. So you can see that this is the same URL that we have here. Okay. And what do we do here actually? For a second. Okay, where were we? So at the beginning, so what does pipe dream actually do? So the application here basically invokes a remote HTTP request over to pipe dream, providing it with some information. The information can be seen here. Whoops, sorry about that. So here we can see the information, for example, provides me, for example, the domain, where I'm calling from, where I'm calling to, and so on. At the end of the process, I'm supposed to get back some kind of XML that looks like this. So how do we do it, actually? So what happens here is the following. So step number 1 here, I've basically defined how my site or how my corporate looks. So I have a set of sites. These, for anybody who writes code, this is all JavaScript. So basically I have a list of sites indicating, okay, start extension is 3400, ends at 3499, and so on. And basically saying, okay, this is the site endpoint, namely the Cloudonics trunk name, as we define here, for outbound trunks. Here, site 3, site 2, site 1. So I basically define them in here. Then I have this step. This step basically says, okay, I'm going to take some information from the request itself, namely the caller ID, the domain, the destination, some session data that I'm interested in. Now here comes the actual magic. Now this code, I know it may look a little bit complex. What it actually does is incredibly simple. So I'm actually taking this list of sites and I'm iterating through it, looking and trying to figure out, okay, the destination that the person dialed, what is it? Or where is it between? What site is assigned to it? Once I have that, basically I'm sending to the console, okay, this is where I'm going to route the call to, and I'm building our XML. The XML here basically says, okay, I'm going to create a message that says routing call to a specific site, and then I'm going to dial the number to that specific site. So the result will be something that looks like this. So I got a phone here on my desk. I'm going to use to dial, for example, in this case, 3500, which is located in site number 2. My device is currently registered to site number 1. And just to make sure that you can see what's happening, I'm going to change the share so you can see it happening in real time. So here I have the 3 consoles of my Asterisk servers, and I'm going to dial to 3500. And that's going to come out of site number 1 here. So you can see it working. Working call to site number 3.
The person at extension 3500 is unavailable. Please leave your message after the tone. When done, hang up or press the pound key.
So you could actually see the call starting on this site and then routed to this site. Now there is no interconnect. There's no route between these two. There is no interconnect. There's just a single interconnect into Cloudonics. Now, if you want, we can have a look here. And this is actually what happened. So you can see that it says extension 3401 was dialing extension 3500. And the result will be here. So it preloaded. This is the site map. Then it processed. Then it said, okay, I need to route the call to site number 2, which basically says site number 2 extensions 3500 to 3599. And it will return me this XML that basically says, okay, I'm going to announce what route I'm going to route to. I'm going to pause for 1 second, and then I'm going to route the call to the specific trunk. Now, the beautiful part here is that Pipedream effectively enables you to build any type of routing logic well beyond just routing. You can do IVRs. You can build your complete enterprise, let's say, service environment using Pipedream, and then integrate the various workflows with other tools as well, such as Salesforce or Zendesk and so on. So there are multiple plugins here that are able to do that. Okay, so I'm going to open the floor for questions. So if you have a question, raise your hand. This is the time to ask these. Also possible putting it into the chat if you can talk or you are a little hesitant about it. Right. Interesting. Okay. It was a little shorter than I anticipated. So this basically concludes the actual technical session that we wanted to do for this webinar. So right now I'm going to stop the recording and we're going to open up everybody's mics for Q&A, and which is going to be completely free-formed, and you're welcome to ask any question regarding Cloudonics, voice over IP, or whatever you feel that you need to know about what we're doing.